Earth is the only habitat for people currently to live as it offers all the resources needed for mankind to survive. But like anything else, it is limited. The current population on Earth has it all, but not the future.
The growing population will face scarcity of resources like oxygen, land, food, water, etc. To overcome this and other challenges like pandemics, calamities, there is a need of an alternate habitat, that is, space settlement.
Space settlement is a complex structure providing the essential needs for a person to live, which is constructed in space.
Stephen Hawking had said, humanity would likely not survive another 1,000 years without escaping beyond our fragile planet. In other words, spreading out into the cosmos is the only way to guarantee humanity's future, our future.
Research is already going on, and in some cases, we have also seen some success. But that's only the tip of the iceberg. Many companies have already taken steps towards it and have also announced projects.
It's all fascinating and futuristic, but filled with challenges like deadly radiation levels, low gravity environments, lack of oxygen, food and water. Most of the water is consumed is derived from the urine and other recycled wastewater. So new techniques has to be developed to make sure it's completely safe to drink. Long duration space missions are exorbitant, leave space debris and are tough on the human body.
Our prototype is the first step towards creating large space settlements. Imagine it like an apartment building or hotel in low Earth orbit. It will pave the way for larger settlements in high orbit space.
The focus of our presentation is on the structural design of the settlement, which is built on Tinkercad software and offers suggestions to following challenges: gravity in space, radiation exposure in space, and providing a breathable atmosphere.
Let's understand how our prototype will work. This proposed settlement can have 2 to 5 residential floors and units for administration and storage.
And therefore, hydroponic farming area, food storage, and all other items that would be required would be stored in the lowermost floor. For emergencies, there is a mini nuclear reactor fitted right on the top for additional power supply.
Living in zero gravity can be painful and exhausting. For creating artificial gravity, we are using the von Braun model. Artificial gravity is the creation of an inertial force that mimics the effects of a gravitational force, usually by rotation.
Although it's not true gravity, spinning the settlement creates a force called pseudogravity that feels a lot like gravity. At 4 rpm, the necessary radius is 56 meters to provide 1 g, which is Earth's gravity. Each flow would rotate at the different velocity depending on its radius to provide 1 to 0.95 g's due to centrifugal force.
Exposure to radiation is a grave threat, and we plan to mitigate it by proposing 2 solutions. Number 1, choice of orbit. The settlement will orbit the Earth in low Earth orbit at around 300 to 400 kilometers from sea level. This is far enough out that the settlement won't crash into Earth, but low enough for the Earth's Van Allen belts, which is Earth's magnetic field, to protect settlers from deadly solar storms.
We are proposing a transparent aluminium with a layer of polythene for the base structure of each floor. Transparent aluminium is one of the most promising materials as it is a ceramic alloy that is 85% harder than sapphire and is resistant to oxidation, corrosion and radiation.
Space radiation can be a problem, but transparent aluminium can help provide some intense protection in space. A layer of polythene will be added to the whole structure for additional protection. Polyethylene is a good shielding material because it has high hydrogen content, and hydrogen atoms are good at absorbing and dispersing radiation.
To provide a breathable atmosphere, we propose that the atmosphere on residential floors will be similar to that of Earth's atmosphere, which is nitrogen 79% and oxygen 21%. To replenish oxygen, we are proposing electrolysis, which uses electricity to split water into hydrogen gas and oxygen gas.
Additionally, algae and plants will be grown to produce food and oxygen. Hydroponic farming will help on all floors to keep them green and produce oxygen.
As mentioned earlier, a few commercial firms are developing space stations which could double as space hotels. These may well be developed in the next decade or perhaps even less. It is estimated that humans may need at least 2 or 3 decades of hotel development to get to the size of a small settlement. Construction of the first settlement could easily take most of a decade.
Given the number of challenges there are, the journey would definitely be full of innovations, experiments, and creativity. We hope you like our presentation of inhabiting space, as clearly it is the future of coming generations. Thank you.